Welcome everyone, my name is Maitresh. I'm going to give a brief seminar about the topic flip-flop conversion. So let us see what is flip-flop conversion. Flip-flop conversion is the process of modifying one type of flip-flop to another type of flip-flop. Either it can be JK to SR flip-flop or SR to JK or JK to B or B D flip-flop to T flip-flop. Any flip-flop can be converted into another flip-flop, and the conversion requires the understanding of truth tables, excitation tables, and the original flip-flop and the target flip-flop to create the necessary logic. So let us see the steps required. The first step is as follows. First, we have to obtain the characteristic table for the required flip-flop. I'm going to give the brief method to remember these characteristics tables for the flip-flop. So let us see remember them easily while comparing between the flip-flops. So let us compare the SR flip-flop and JK flip-flop. So in SR flip-flop, the main difference is below occurs below this line. So the upper part is always same. So I'm going to give a method or a small technique for remembering this upper part. So then for when the SR flip-flop is SR is 0 0, then the output, then the present state condition is reflected onto the next state condition. If the present state is 0, it will be 0. The present state is 1, it will be 1. Next, if the SR flip-flop is 0 1, then the present state can be either 0 or 1. The next state is always 0. Similarly for JK flip-flop, if the JK is 0 or 1, then the next state present state is 0 or 1, then the next state is always 0. So next one, for SR flip-flop, it is 1 0. Then the present state is either 0 or 1, then the next state is always 1. Similarly for JK flip-flop, if the J is 1 and K is 0, then the next present state is 0 or 1, then the next state is always 1. So here is where the change between the JK flip-flop and SR flip-flop occur. For SR flip-flop, if SR is 1 1, the present state is 0 or 1, then the next state is in don't care condition. And for JK flip-flop, if the JK is 1 1, then the present state is 0 or 1, the next state becomes the Q and bar, that is present state bar, that is if it is 0 it becomes 1, if it is 1 it becomes 0. This is the if it remembers SR and JK flip-flop characteristics table. So let us see the T flip-flop. In T flip-flop, if the input is 0 and the present state is 0, then if the input is 0, the present state Qn is automatically reflected into the next state as Qn. As we can see, if the input is 0, then the present state is coming directly into the next state. And for next one, if the present state is 1, then the Qn in next state becomes Qn bar, as you can see here. Let's just go to the D flip-flop. In D flip-flop, if the present state is 0, the next state can be either 0 or 1. Then the present state is either 0 or 1. Then the next state is the value of the input, that is 0. So here in basically what happens in the D flip-flop is the present state is always projected into the next. The input is always projected into the next state directly. The present state can be anything. It will be like don't care condition of the whole present state. So let us go to the next one. The next step we follow is to obtain the excitation table of the available flip-flop. So let us see the excitation table. The excitation table of the flip-flop are as follows. So for SR flip-flop, the excitation tables occurs between we have to write for present state and next state we have to write for SR. So let us compare the SR flip-flop. In here we can see that for the present state 0 and next state 0, the SR flip-flop 0, 0 and don't care condition. Similarly for JK flip-flop also. And if we see this one, if the present state and next state are 1 1, then the SR flip-flop becomes don't care 0. Similarly for JK also. Here the change occurs in JK and SR in this area. Here. So let us see the change. If the present state is 0 and next state is 1, then the SR becomes 1 0. As for the JK flip flop, if the present state is 0 and the next state is 1, it becomes 1 don't care. As we can see here, in 0 place there is don't care condition. This is one easy way to remember the JK flip flop from SR or vice versa. So let us see the next condition, that is 1 0. It becomes 0 1. SR becomes 0 1 for present state 0 and next state present state 1, next state 0. So in JK flip flop, if the present state is 1, next state is 0, then it becomes don't care 1. That is like this. So let us go to the next one, that is T. For T, as we can observe here, if the input present state is 0, then the next state is directly projected into the T. Next state is directly coming into the T. If the present state is 1, then the Q and next state is directly projecting as Q and next state bar. That is, if next state is 0, it will be becoming 1. If the next state is 1, it becoming 0. And for the BE, if the present state can be anything, but if the next state is 0, the B becomes 0. If the next state is 1, it becomes 1. If similarly, if this is the same condition, the the present state is similarly taken as the don't care condition. So what is the next step? Obtain the expression for input of the inputs of the required flip-flop and present state variables for the existing flip-flop and implement them. So let us apply this in a problem to understand this. So here is a problem. Here the problem states that to conversion of D flip-flop by using SR flip-flop. So here we have to convert from D flip-flop to SR flip-flop. From here we have to understand what are available and required flip-flop. So here the available flip-flop is SR flip-flop, from which we have to convert it into the D flip-flop. So available flip-flop is SR and required flip-flop is D. So as we studied in the previous steps, for SR for the required flip-flop we have to have the characteristic table, and for available flip-flop we have to write excitation table. So let us take the characteristic table of D flip-flop and excitation table of SR flip-flop. As we have seen in the previous slide, here are the characteristic table and excitation table of the flip-flops we required. So the next step is as follows. We have to write the inputs. So how to write the inputs? From the excitation of a characteristics table, we will write this. This is one. From the previous slide, it is clear that in previous slide, from here we will write the characteristic table. From characteristics table, we will add SR with respect to the Qn plus 1 in the next table. So let us see this table. So here the SR are written with respect to the Qn plus 1 state. So from this table we will write the k maps. We have to do k maps for get the SR and k values, so we can convert them. From here you can already, for getting S, we have to do a k map between these two. So as we can see here, the k map is as follows. The k map is given. We will try to do k map. Then for 0 0 S is 0, we will not write anything. For 0 1 S is 0, we will not writing. For 1 0 S is 1, so we will write 1. For 1 1 S is don't care condition, so we will write don't care. The pairing will be like this. After solving, we will get S is equal to D. Similarly for R, we will do the same. Let us see this. For R, it will be 0 0 R don't care condition, so we will write don't care. Then for 0 1 R is 1, so we will write 1. And for 1 0 the R is 0, we will write not anything, and we will pair this, and after pairing we will get R is equal to B. So we will get, we have got an S and R, so we will apply this directly. So let us take a SR flip-flop. From SR flip-flop we have to convert into D, so apply this k map we got. For to S we have to connect D directly, and to R we have to convert D bar, so we will write and not get. This is very simple, right? Isn't it? Let us practice another problem to get very clearly. So the next problem, it is here. The problem is to conversion of T flip-flop to SR flip-flop. It is very direct. We have to convert the T flip-flop into SR. So what is the required flip-flop? It is SR. And what is the available flip-flop we have is T. So for T flip-flop we write the excitation table, and SR flip-flop we will write characteristic table. So let us write them. So here is the excitation table for the T flip-flop and the characteristic table for the SR flip-flop. So for characteristic table, in characteristic table, with respect to the Q and present state and next state, we will add the T to get the inputs. So let us see the table. Here is the table we require. So here is the toggles with respect to the Q and Qn plus 1. To get the K map, so we have to do the K map to get the. In previous turn we done differently for S and R. In here we only have to get one, that is for toggle condition. So for toggle there is only one input in toggle log gate. In toggle flip-flop there is only one input T, so we will have to do K map only one. So we will do it like this. We have to do with respect to like this. So 0 0 0 K map for S, R and Qn. 0 0 0 the toggle is 0, so we will put 0. And 0 0 1 the toggle is 0, we will not put anything. And 0 1 0 toggle is 0, we will put 0. And 0 1 0 the toggle is 1, so we will put 1 there. And 1 0 1 the toggle is 1, we will put 1 there. And 1 0 1 and the toggle is 0, we will leave it. Then 1 1 0 the toggle is don't care condition, put the don't care condition. And 1 1 don't care condition, it will be again don't care condition. So if we do like this pairing, we will get this. After the pairing is completed, we will get the equation. If we write the equation, we will get T is equal to like this. So then first we have to write a toggle flip-flop like this. After writing the toggle flip-flop, we have to apply the T condition. For let's take is SR, and for toggle we have to convert the SR. So from here you will take it like this and put it to SR for end, and connect S. Similarly to R, and we will get and we will put this link directly to the T like this. So we got the logic gate required. So let us see some applications for the conversions. The flip-flop conversions are used to build digital systems like color counters, shift registers, memory units, which are fundamental for data storage and process and transfer. They are essential for frequency division, creating latches, which are used for temporary data. And additionally, the flip-flops are used in synchronous for creating bouncing circuits to clear up noise mechanical switch inputs. So the conversion of flip-flops is very important, which are can be used in daily life also. I hope you learned something new. Thank you.